Hello class! Welcome to another episode, and this is another video lesson for illustrating lines, secant, tangent, and segment associated to a circle. This is for grade 10 mathematics, quarter 2, week 5 of version 5. Are you ready? If you are, let's go! The objectives for today's lesson: at the end of this session, the learners would be able to illustrate and show examples on secant line, tangent line, and segment associated to a circle. Number 2, illustrate sector and segment of a circle, and solve problems involving sector and segment of a circle. Now, let us have a little review and a bit of additional related terms. First is circle. Please don't forget the definition of a circle. Say we have here a center and a circle. Say circle M. Now, let's consider this figure for circle M. Then, we are going to identify the radius. The radius is, a line segment connecting the center and any point on a circle. Like, say we have from the center M, we have a point on a circle which is A. Now, MA is an example of a radius. Diameter. Take note that the diameter is the longest chord of the circle because its length is equivalent to 2 times the length of the radius. An example of the diameter is this one. A diameter always passes through the center of the circle, and this diameter is the line segment SR. Next is the arc. Now we can see there many arcs in the figure. Okay, let's take a look at the arc AR. The arc AR is just an example of the minor arc. Another minor arc is SA, and of course a semicircle SR. Central angle. A central angle is an angle whose sides are radii of the circle. Just like this, we have there theta. The Greek alphabet theta usually represents the measure of an angle for geometry. So there we have an angle AMR, which is a central angle. Next is tangent line. A tangent line, say this line L, is tangent to the circle M if and only if it passes through an exactly one point of the circle M. Say the point is T. Take note that when there is a tangent line and we are going to identify the point of tangency and draw a radius from the point of tangency, then that radius is perpendicular to the tangent line L, meaning to say it forms 90-degree angle. Now, secant line. Secant line is a line that passes through 2 points of the circle. Say we have a circle M, then our secant line is the line M. Take note that line M passes through points S and A. And if you are going to observe closely, SA there is a chord of the circle M. I hope you will not forget that one. And also, we have inscribed angle. Say we have there the angle ASR. An inscribed angle is formed by 2 chords of the circle. Please don't forget these terms. Let's go to the lesson proper. Arc length. Consider the circle on the right later. First, let us going to identify what is an arc length. An arc length is a portion of a circle's circumference. What you can see there in the yellow circle on the right, the length of that is called the circumference. And any portion of that is called the arc length. And the length of the circumference is represented by the formula C equals 2 times pi times r. Since it is an arc, we're talking about the arc length, then its degree measure is equal to its central angle. Now, the formula of the arc length is L equals the theta, the central angle, divided by 360 degrees times the circumference, which is the 2 times pi times r, where pi is equal to the constant 3.14. Okay, now let us check the circle. Now let's have the circle C here. In the circle C, we can have the arc. Okay, as you can see there, the red one is an arc. Now, if we're going to solve for the arc length, so let us consider the end points of the arc length, which is AB. Now, to solve for the length of that arc, we need to find the length of the radius. Okay, so take note that we have there two radii, the CB and the CA. And aside from the length of the radius, we also have to identify the central angle, which is the theta. Now let us proceed with the example in solving for the arc length. Example 1. An arc of a circle measures 45 degrees. If the radius of the circle is 6 centimeters, what is the length of the arc? Okay, so from that problem, we are going to, of course, identify our given, which are the central angle, which measures 45 degrees. So the central angle which measures 45 degrees. Then we have our radius equals 6 centimeters. And of course, our pi is the constant 3.14. Then we are going to make use of the formula, where arc length is equal to the central angle divided by 360 degrees times the 2 times pi times the radius. Okay, so taking all of this, let us substitute the given to the formula. Now, the central angle is 45. Then, our pi is 3.14. So, 2 times 3.14 times our radius, which is 6 centimeters. Then, we are going to solve 45 over 360. If we're going to reduce that to the lowest term, it is equal to 1/8. And 2 times 3.14 times 6, that is 37.68. Please do the calculations later. Please screenshot this portion of the video. Now, 37.68 divided by 8, the arc length is equal to 4.71 centimeters. So, this will be our answer to the example 1. I hope you understand that one. Let's go. Now, another topic is the area of a sector of a circle. Take note of the figure on the right. It is a shaded circle. A yellow circle shaded with the pink color. Why? Okay, later I will going to explain. When we talk about sector of a circle, then it is a portion of the circle's area. So the circle itself has no area, but when we are going to consider the enclosed area of the circle is now we can have the area. An example of this, a concrete example, is the coin. Take a look at the coin. I mean, say 1 peso coin, 5 peso coin, then it's the whole thing is consists of an area given that radius. Okay, so that is why we have here a formula. Area of the circle is equal to pi r squared. Take note, a sector of a circle is a portion of a circle's area. So we'll be using this formula, area equals pi r squared. Next, since it contains an arc, then its degree measure is equal to its central angle. So from the definition 1 in, okay, our last topic, actually, previous topic, the last topic, which is the week 4. Okay, so the formula of the area of a sector of a circle is given by, okay, so A sub S represents area of a sector of a circle, is equal to the theta, which is the central angle, divided by 360 degrees, because it's a portion of the whole area of the circle, times the area formula, which is pi r squared. To understand this better, let's proceed with the example, which is now to understand this better, let us take a look at the figure. So we have there a circle C. Now the circle C has that portion. Now to imagine the area of a sector of a circle best is to think about a slice of a pizza or a pizza pie. Okay, so just like that, it's a 1/4 of the area of the circle. Now, since we have that figure bounded by an arc and radii, so we have there an arc AB. Okay, so now the sector of a circle is just like that. Okay, so a slice of a pizza, as what I've said. Now, since that is a slice of a pizza, the arc there needs the measure of the central angle. Okay, so let's proceed with the example. Example number 2. A central angle of a sector has a degree measure of 120 degrees. If the radius of the circle is 10 centimeters, what is the area of the sector? Solving, we are going to identify first the given. So we have there the central angle, which is 120 degrees. Then the radius is 10 centimeters. And of course, we are going to make use of the constant pi, which is 3.14. Okay, using the formula, area of the sector, which is equal to central angle divided by 360 degrees times pi r squared. So taking these things, let us substitute the given. So we have there 120 for theta, then 3.14 times 10 squared. So simplifying 120 divided by 360, it's 1/3 times 3.14 times 10 squared, which is 100. So 100 times 3.14, that's 314. Now 314 divided by 3, the answer is 104.67 centimeters squared, because take note, it's a portion of an area of the circle. So please check the calculations later, so please screenshot this portion of the video. So our final answer for example 2 is 104.67 centimeters squared, or square centimeters. Okay, I hope you get that. Let us proceed with the activity. Okay, so we have here 2 activities. The first problem is a central angle of a sector has a degree measure of 90 degrees. If the radius of the circle is 8 inches, what is the area of the sector? Number 2, find the arc length whose central angle is 180 degrees and the radius of the circle is 4 inches. Easy. So let's go. Let's answer number 1 first. So this is the problem. Then the given are, okay, the theta, which is 90 degrees, and the radius is 8 inches. Of course, don't forget the pi, which is 3.14. Then the formula for the area of a sector of a circle is the central angle divided by 360 degrees times the quantity of pi times r squared. So solving, substitute 90 degrees and 8 inches radius. So we have 90 over 360 times the quantity of 3.14 times 8 squared. Now, 90 over 360 is just 1/4. Its lowest term is 1/4. Then 3.14 times 64, or 8 squared is 64. The answer is 200.96. Now 200.96 divided by 4, the area of a sector is equal to 50.24 square inches, or inches squared, or square inch. Okay, so this is our answer for number 1. For number 2, find the arc length whose central angle is 180 degrees and the radius of the circle is 4 inches. Simply identify the given central angle is 180 degrees, then the radius is 4 inches. Mean to say we are talking about a semicircle here. So the length of that semicircle may be solved or can be solved by this formula. Central angle divided by 360 times the quantity of 2 times pi times r. Then, let's substitute this given 180 over 360, or divided by 360 times the quantity of 2 times the pi, which is 3.14, times the radius, which is 4. 180 divided by 360, in Lewis term, it's 1/2. Then 3 times 3.14 times 4, it's 25.12. So 25.12 divided by 2, the arc length for problem number 2 is equal to 12.56 inches. And that is our final answer for number 2. Any questions? If you have question, please don't hesitate to type it in the comment section. Thank you very much. Now, for your assignment, please answer these problems in a 1/2 sheet of paper and submit your answer to your mathematics teacher. Okay? So, this is due next week. So, please do it, class. Thank you. Thank you very much for watching. I hope you learned something new today, especially the terms tangent line and secant line. Also, the arc length and the area of the sector of a circle. Thank you very much for your active participation and for viewing this. Good job, everybody. I am Mr. Anthony G. Arisgado, Grade 10 Mathematics teacher of Bukidnon National High School. Math is fun and math is for everyone. Bye-bye!